Hi, this is question number 5 from the AQA Core 2 January 2015 exam paper. For the first part of this video, I'd like you to try the question yourself. So if you'd like to pause the video and try the question now. Okay, well done if you managed to have a go at that. For the next part of this video, I'm going to give you a hint as to how you could go about answering this question. So we've got the nth term of a sequence that we're going to call un. The sequence is defined by un plus 1 is equal to p times un plus q, where p and q are constants. The second term of the sequence is 160, and the third term of the sequence is 132. The limit of un as n tends to infinity is 20, and for part A we need to find the values of p and the values of q. So in order to solve this, well, because we know two consecutive terms here, we know the second term and the third term, then I can set un here to be u2, which means that would be u3. Okay, so I know what u2 is, the second term is 160, and I know what u3 is, it's 132, so I can come up with an equation for that. We can then come up with another equation because we're told that as n tends to infinity, un approaches the limit, which is 20. So that means that as un and un plus 1, because they tend to a limit, they're going to get closer and closer together. And we're told you that as it tends to infinity, they're going to get closer and closer to 20. So to work out what p and q are, we can set un and un plus 1 both to 20. And then we've got another equation. We should now have two equations, and we should be able to use them to work out what p and q are. Okay, part B says, hence find the value of the first term of the sequence. Well, we know the second term of the sequence, so we know u2. So we can set un to be u1, and then we know what p and q are at this stage, so we should be able to work out what the first term is. Okay, I'd now like you to pause the video and see if you can now have a go at answering the question. Okay, for the last part of the video is I'm going to go through a full solution for this. So for part A, we need to find the values of p and the values of q. The second term of the sequence is 160, so u2 is equal to 160, and we also know that u3 is equal to 132. So if I sub that into here, I've got 132 is going to be equal to p times 160, or 160p plus q. Okay, so that's one equation. Okay, and because un tends to a limit of 20 as n tends to infinity, these un plus 1 and un are going to get closer and closer together and reach a limit of 20, or approach a limit of 20. So to work out what p and q are, I can say that 20 is going to be equal to p times 20, or 20p plus q. Okay, so I can now solve these two equations simultaneously. If I multiply both of them by 8, if I multiply this second equation by 8, I get 160 is equal to 160p plus 8q. I can now do this equation, take away the top one, so 160 take away 132 is going to be 28. 160p take away 160p is 0, and 8q take away 1q is going to be 7q, which tells me that q is equal to 4. I now know that q is equal to 4, so if I sub into this one, I've got 20 is equal to 20p plus 4, so 20p is going to be equal to 16, and p is going to be equal to 16/20ths, which is just 0.8. Okay, so q is 4 and p is 0.8, and that's part A. Part B says hence find the value of the first term of the sequence. Well, using this here, I know that u2 is going to be equal to p times u1 plus q. u2 I know is going to be 160. That's going to be equal to p, which I now know is 0.8, so it's going to be 0.8 times my first term plus q, which is 4. So 0.8 u1 is going to be equal to 156, and u1 is going to be equal to 156 divided by 0.8. And that gives me 195. So the first term of this sequence is 195. Okay, I hope that was useful. Thanks very much for joining me. I'll see you next time.